Hello, my name is Jacqueline Ebergall, and today I will be giving you a PowerPoint presentation on nuclear fusion and nuclear fission. Nuclear fusion is the process of making a single heavy nucleus from two lighter nuclei. This process is called a nuclear reaction. The nucleus made by fusion is heavier than either of the starting nuclei. However, it is not as heavy as the combination of the original mass of the starting nuclei. This loss of mass is what is converted into energy in Einstein's famous E=mc² equation. Fusion happens in the middle of stars, like our sun. Hydrogen atoms in there are fused together to make helium, and this releases a lot of energy. This energy powers all of the heat and the light of the star. Not all elements can be joined, however. Heavier elements are less likely to fuse with other atoms. This is what causes a star to eventually die. Stars join all of their atoms together to make heavier atoms of different types until they start to make iron. The iron nucleus cannot fuse with other nuclei and the reaction stops. The star will cool down and die because of this. Both nuclear fusion and nuclear fission are nuclear reactions that produce energy, but the application are not the same. Fission is the splitting of a heavy, unstable nucleus into two lighter nuclei. The fission is the process where the two light nuclei combine, releasing vast amount of energy. During the fission process, energy is released as less energy is now needed to hold the nucleus of each of the smaller nucleids together. The energy release is one fission is about 1 million times greater than the most energetic chemical reactions. Nuclear power comes from the process of nuclear fission, or the splitting of atoms. The result, called nuclear chain reaction, creates heat, which is used to boil water, produce steam, drive turbines that eventually generate our electricity. Nuclear power. Nuclear power comes from the process of nuclear fission, or the splitting of atoms, and it is very important to our functions as a species on Earth. 1 in 5 households for us and businesses receive their energy from nuclear sources. Nuclear power facilities can produce energy at 91% efficiency rate 24/7 with virtually zero carbon emissions. 13% of the world's electricity comes from nuclear power. Nuclear power plants run on uranium, an element that is so energy rich that a single fuel cell can contain as much energy as 17,000 cubic feet of natural gas, or nearly 2,000 pounds of coal. Nuclear power plants actually emit fewer radioactive materials into the environment compared to traditional coal burning, which does surprise a lot of people. It is estimated that nuclear facilities can save 1.48 million lives since the inception of it has prevented the release of lots of harmful pollutants into the atmosphere. Modern nuclear plants produce electricity for just 4 cents per kilowatt, compared to solar energy, which can be up to 16 cents per kilowatt. With all of the amazing advantages that come with nuclear energy, there is also dangers of it. Nuclear energy creates waste. As you can see on the beyondthebomb.org waste map, there are many locations in the United States where we are burying below us lots of very radioactive garbage. Every day, nuclear power plants run on nuclear energy and are creating lots of super dense, super radioactive waste. This problem of waste is never answered, but it's rather literally buried away to become a future generation's hazard. Humans have also weaponized nuclear power. That nuclear waste can be turned to warheads, and we have seen many wars from it. U.S. mining is also harmful. Uranium mining is also harmful to the environment and to the workers that are put into those situations. Meltdowns are also a catastrophic event that can be happening with lots of casualties in the future as long as we do keep using nuclear power plants. An example would be Chernobyl with 6,000 deaths, or Fukushima that had 2,000 related deaths. And let us not forget 3 Mile Island, which was just in our backyard. There are alternate energy sources to nuclear energy. It is not the only answer. Solar power is one. Solar power is abundant, it's inexhaustible, and argumentably the best known alternative energy source to nuclear power. The most common method of harnessing this energy is through the use of solar panels, that's direct sunlight into electricity. Natural gas is also an alternative energy source to fuel. It is it's not a typical fossil fuel, but emits less carbon and other harmful pollutions compared to coal. Water and hydroelectric power is also an option, just as it works in similar ways to air power and solar energy. And you can also mine things besides uranium. Hydrogen and thorium are both abundant and less volatile than uranium. Hydrogen gas burns cleaner and it can be produced domestically, and it's also 3 times more efficient than oil. For my bibliography, I used several sites in which I got my statistics. I got the answers to pretty much how fission works in our everyday life here, some research on the waste process of it, and then Beyond the Bomb.org with some more of the dangers in it.